Okay, today we're going to learn how to solve inequalities. A big skill that you will need is factoring. At this point, I hope you can factor. I expect that you can factor. I am not going to show you how to factor anything today. Anytime we come to a factoring problem, we're going to pull up Factor Poly and have the calculator do it for us. So we've got a few programs we're going to be learning how to use throughout the rest of the year. But anyway, so this one, x cubed minus 3x squared plus 2x equals 0. Everyone agree? This is the only one I will probably factor by hand. I'm going to factor out an x. Why did I get 0 on one side? Just out of curiosity. That is the only way I can solve by factoring, right? Had a greatest common factor of x. So we have x and x, 2 and 1. So x is 0. Show you how to use the calculator to do that. You can do it. If you go to Program, there's a new program on your calculator called Factor Poly. Click it. The first thing it asks is the degree. What is that? The highest power. Factor Poly didn't? Cosine.
Oh, there we are.
Okay. What is the degree? 3. So I'm going to type that in to degree. What is the coefficient of the x cubed? 1. So you have to know some math words to use this program. What is the coefficient of the x squared? -3. What is the coefficient of the x? 2. And what is the constant? 0. Now, what do you know?
Yeah.
Why did you go that
I'm pulls up there.
Program, Factor Poly, push enter.
It says memory is insufficient.
So, at some point after class, bring me your calculator. We'll have to clean up you got too much stuff on your calculator. Okay, again, bring me your calculator after class and we'll check. Blurry? Yeah, we'll have to do it after class though, because I've got a lesson I've got to do. So, but we can do calculator troubleshooting later. The degree is 3. The coefficient of x cubed was 1. Coefficient of x squared was, what was it? -3. Coefficient of x was 2. And the coefficient, or the constant, was 0. You type all of that in, and it factors it. What is a constant, James?
I don't know the definition.
It's a number without an x beside it. Now, let's talk, because I heard some of you already angry with me that you didn't know this before. Have y'all seen those ACT problems that it doesn't help for you to be able to use a program where they make you find A and B where this factors? Okay, if you don't know how to factor, you're at a huge disadvantage on the ACT. You have to know how to factor by hand. When you come to a difficult factoring problem, Factor Poly can help. If you use, listen, I can't talk over you. If you use Factor Poly to factor easy factoring problems on the ACT, you will not finish. You know what I mean by that? Factor Poly takes a lot longer than what are the factors of 2 that add to give me 3? Oh, 1 and 2, done. That's a lot faster than pulling up Factor Poly. So you do not want to become where your calculator is a crutch. It is a great aid. don't make it a crutch, or you won't finish the ACT. You know what I mean by that? So that should answer your question on why you haven't seen it yet. You needed to know some basic skills, and if I had given you this, you wouldn't have learned them because you would have used it the whole time. But you already have those basic skills, we hope, at this point. And so now we can use factor poly to do some things that are complex or, Anyway, throughout the rest of the year, I will throw up a few more problems where we will use those ACT programs and stuff. I'm not going to teach you all of them today. We do have a lesson today. I encourage you to play around with it. Quad 3 does the quadratic formula. So that's what that one does. You can play around with that at some point. Today we're going to learn how to solve inequalities. If you had a problem with a calculator program, like I said, bring me your calculator after class and I'll do some troubleshooting. Inequalities are when two equations are not equal but less than or greater than. And there are two ways to solve them. You can solve inequalities graphically and you can solve them algebraically. We're going to look at both today. The ACT will occasionally put a problem that is strictly a graphing problem that looks like this. So, this says, solve the following inequalities. To solve an inequality, it's not just one answer, right? Because an equation could be less than in a lot of different places. So we're going to use interval notation. So let's look at these two functions. F of x is the gray colored line. Does everyone see that? F of x is the gray color. G of x is the bold color line. So the first question asks, when is f of x less than g of x, less than or equal to g of x? What should that look like graphically? First of all, let me ask you a simpler question. What is f of x the same as? Good, it's the same as y. So I want to know when the y value on f is less than the y value on g. So wouldn't that be when the gray line is below? So it'd be here and then all of this, right? Now, how do we answer a graphing question? When I want to say from here to here, what kind of values do I give to answer that question? X values. Same thing with increasing and decreasing and all of the, if I want to tell you where on a graph I use X. Well, would you agree it's from here backwards, right? So from negative infinity to negative 2. I am going to bracket. Someone tell me why I'm bracketing that 2. It says or equal to. Aren't those two graphs equal at negative 2? That's where they intersect. So I'm going to include that. And then from where to where? 2 to 10. Very good. All bracketed. Any questions about that one? So the next one says, when is g of x greater than or equal to f of x? Negative 2 to 2. I would say if this graph stopped, that's where I would stop. It does appear after the 10. Would you agree that the and it's hard to see, so I'll forgive you on that one, but it does, don't you agree it goes back above up there? So from 10 to infinity. This is almost the same question as, no, it's, hold on, whoa, y'all let me mess up. Y'all let me trick you. Oh, I'll hold that up there for a minute. Okay. I should read my questions before I answer them. Okay, let's try this again. G of x greater than or equal to f of x. What's that mean?
Whenever the sum part is greater than the not size part.
Okay, when the solid line is greater than the not solid line. Isn't that the same question as this one? Yep. Sorry, it's my fault. I should have caught that. Isn't this the exact same question as this one written differently? When is g of x greater than or equal to f of x, right?
Mm-hmm.
So this is the same answer. Okay, now let's talk about the third one. Does everyone understand why that's the same question? No. G of x greater. When is g of x greater? See how the alligator's eating G both times? So it's the same question written backwards. Okay, let's talk about non-brackets. This is just a greater than symbol, right? So when we're just greater than, do we want the intersections included? No. So on f of x greater than g of x, that would be the red parts, right? F of x greater than g of x. Now, this time, I did already answer that question, but this time I'm not going to put brackets. Why am I not going to put brackets? Because not equal to. I don't want to know when they're equal. I just want to know when f of x is greater than g of x. Yes?
On the first one, it's when is f of x less than g of x? But
Less than or equal to.
Yeah. But on the second one, if it's talking g of x, it's a different line.
It is, but g of x is greater than. So that's
So
asking.
wouldn't that be from 2 to 10?
It is from 2 to 10.
Oh, yeah, okay.
So the difference in this question and this question, and I'm sorry I messed up, I just wasn't even reading. I need to read. But the difference in those two questions would be, everyone listen to this. Does Susie have more money than Bill? Does Bill have less money than Susie? You see how those say the same thing? They are said differently, but they are the same thing, and so that's the difference in those two questions. Okay, how to solve them algebraically. We're not finished with the last one, is that what you said, James? Yeah. Do you have any questions about it? We'll talk about note cards when we start reviewing. Okay, solving inequalities. Get 0 on one side, solve the related equation. Find out all solutions and restrictions. You may use your calculator to do all of that. Or you can do it by hand. We'll talk about both. Draw a number line with all solutions and restrictions listed. Choose values between the numbers, positive and negative. You may use a calculator to do that and look at when it's above and below the x-axis. Not right now. We'll talk about note cards on another day. We gotta go. And step 5, decide which values make your inequality true. Write the solution in interval notation. Okay. I'm going to show you a combination of by hand and calculator skills on this. You can choose to go all calculator. You can choose to go all by hand. You can do it however you want. As long as you get the right answer, no one will complain on how you do it. So I want you to have kind of a look at both. You'll probably pick a combination of the two or something. Step 1, because some of these can get complex, the first thing I want you to do is always get 0 on one side of the inequality. Now, this probably looks like a familiar equation. Does it look like a familiar equation to you? It's the bell ringer, right? Except instead of equals 0, it's greater than 0. So step 1, get 0 on one side. Step 2 is solve the related equation. What that means is solve this equal to 0. I don't care how you do that. You can pick up your calculator at this point and go to y equals and type in that equation in y equals. Is that a skill we have already? Yes. You can solve the equation in y equals by graphing and finding intersections. You may have to zoom in a little on this, but 0, 1, and 2. Now, where else could you get those if you didn't want to do that just graphically? Did we get 0, 1, and 2 on the bell ringer? Did we graph anything on the bell ringer? So you could do it graphically, you could do it by factoring, you could do it completely by hand. It doesn't matter to me how you get those 3 answers. Okay, does everyone see how we got that? Take those 3 answers and put them on a number line. Was it -2, 1, and 0? Or no, 0, 1, and 2 was it? Do what? Why? Well, that doesn't seem very founded. Reason for it. All I did was put numbers on. You should be so far. Okay, any questions so far? Okay, before 0, I want to know if the function is positive or negative. 2 ways to tell. Go back to the graph for a second. To the left of 0, is this below 0 or above it? Below. Wouldn't that be negative? Okay, so that's one way to do it. I can say it's negative because it was below the x-axis. The other way to do it is plug in a point. So if you were doing this solely by hand, those of you who like to do things by hand, in factored form, it would be easy to plug in -2, and you could just see if it was positive or negative. Or you could go to your table in your calculator and plug in -2. If I do, I get -24. I don't care what the number is. The big thing I want to know, is that a positive number or a negative number? I'm going to do the same thing in between each set of points. So between 0 and 1, if I look at the graph between 0 and 1, where is the graph between 0 and 1? Positive. Does everyone agree? Above the x-axis. If you are unsure, what's a number between 0 and 1? 0.5. Do I get a positive number when I plug in 0.5? So you have 2 options there. You can plug a number in, or you can look at the picture. Doesn't matter which one.
You can just put that in the table. You just do 0.5 in there.
Yep. So you tell me, between 1 and 2, am I positive or negative? And between, from 2 on. Okay. Now I want to solve this inequality. I want to know the x's when x is greater than 0. What kinds of numbers are greater than 0? Positives. Everyone agree? Positive numbers are greater than 0. So 0 to 1 and 2 to infinity. Why did I do parentheses? Hunter. Why did I do parentheses? You don't have to answer.
Doesn't say equal to.
It's not equal to, right? It's just greater than, not greater than or equal to. So I'm just going to put a parenthesis. If it were greater than or equal to, then I would put a bracket. Okay, the next problem is very similar. You'll notice it's the same equation. That's a minus sign, not an underline or anything weird. So my number line, wow, let's try that again. That's what I get for sitting over here. Cheat. So my number line looks the same. In fact, even the pluses and minuses are the same, aren't they? Because it's the exact same equation. Except this time, what's the question asking? Less than or equal to 0. What kinds of numbers are less than 0? Negatives. So negative infinity to 0.
Bracket.
Why bracket?
Equal to.
Good. And then 1 to 2. Any questions about that? That's how you solve inequalities. We're just going to do more examples for the rest of class. Again, there is no shame in using a calculator when you need one. You are welcome to do it by hand, but you are also welcome to pick up a calculator to look at the graph or however you want to do that. This one's nice because 0 is already on one side. So step 1, get 0 on one side, done. Step 2. What's step 2? Solve by factoring, right? If possible, solve by factoring. If not, pick up a calculator. They did all the work for me on this problem. Do you agree? They already factored it for me. So what are my numbers that go on my number line? -3. I heard someone say -3. Where'd you get -3? What makes x plus 3 equal 0? And then I heard 2 and 5. Now, does it matter what order I put them down in? Yes, it very much matters what order I put them down in. What order do I need to put them down in? In least to greatest, numerical order. I'm going to type this in my calculator. I am going to show you this one on how you could do this one completely by hand. But I'm going to have it in my calculator to also show you how we can use the calculator. So I just typed that equation in my calculator. I do have 0 and y2. If you were having a hard time telling what the zeros were, use your intersection button and find them, right? Remember, you don't have to do anything by hand if you don't want to. Because it's already factored, it's almost harder not to do it by hand. But remember, it's an option. So I have this graph. Okay. Any questions so far? I want to take a number less than -3. Someone tell me what's a number less than -3. -4 and plug it in. I could even do that by hand, right? I would get a negative number times a negative number times a positive number, and that would give me a positive number. Those of you who care to know completely by hand, that's how you would do it, completely by hand. The rest of you who don't care to ever know that, look at the picture. Is it above the x-axis? It's positive. What about after 3? Is it still above the x-axis? So it's still positive from -3 to 2. Again, if you were unsure, go to your table, -4, -2, right? Positive and then positive again. Does everyone see how we're getting that? A number between 2 and 5. Oh, it's negative. You were answering the question. I thought you were telling me like -2. I'm like, no, that's not between 2. Yes, you're right. And then after 5. Okay, let's look at the picture, make sure everyone agrees with that. Do you agree we're positive, positive, negative, then positive? Everyone see that from the picture? So let's answer the question. When is this less than or equal to 0? First of all, when is it less than 0? Between 2 and 5, and at 2 and 5 we equal 0. Because of this weird plus thing, let's also ask the question, is there anywhere else that it actually equals 0? At -3? Do you agree it equals 0 at -3? So I want to include that. I don't care how you write that, if you just want to write a -3 and then, by the way, but we do want to include the -3. So that one was kind of tough because of the -3 equaling 0. Okay, let's look at the next one. What do I need to do first? It's 0 on one side. Okay. What do I do from there? Put it in the calculator. That is one correct answer. Someone give me another option. Factor it. Who's right? Both of you. It just depends on how you want to solve the equation. If you do that in your calculator, you can, this one, I'm going to show you this one completely in the calculator. That way if you come to one where you have to do in the calculator, you can. I have 0 and y2. Does anyone remember why I put 0 and y2? So I can find the intersection. So I can go to second trace 5 and push enter 3 times. And I get -1 is one of my points. And then second trace 5, move over to the right. Is it 6? So I get -1 and +6. Oh, I got -1 again. Sorry, I didn't move far enough to the right. I moved farther. The by hand option, x -6, x +1. Everyone agree with that? Number line, -1, 6. And it was positive, negative, positive. It was above, below, above. I'm looking for above, so I'm going to do -infinity to -1, 6 to infinity. Notice I did all parentheses. Why? It's not equal to. Okay, let's look at this next one. I'm not actually going to do it because I'm going to go on to one other example. It looks horrible, doesn't it? Put the 16 on the left, put it in y1, find the intersections. Don't make it horrible, right? You just do it. That one is one that I would probably go calculator to solve, because the solving is a little yuckier. Let's talk about this one. It's a little different. 0 on one side. Okay, step 1, get 0 on one side. Step 2, solve it, right? How many of you, that one looks kind of yucky to solve? We haven't dealt with a lot of rational equations yet. Looks a little yucky, right? Use your calculator. So I'm graphing it. Would you agree that somewhere in here I changed from being positive to negative? Could you use the trace button to find out where that somewhere might be? Does anyone have a guess on where that is? Let's find out. I'm going to trace. So right now I'm at negative 0.8, negative 1, negative 1.7. Up, and then at negative 2.1, I jump away up here. So negative 2, does everyone agree that looks to be at negative 2? The reason that is it makes the denominator 0. What do we know about denominators being 0? What do we know about denominators being 0? What's your calculator do when you try to make a denominator 0? Error, right? So in that error place, we could have a change from positive to negative. So I'm going to put it on my number line, but I'm going to mental note that it's undefined. So James, this might answer your question. And then the other thing I'm going to put on there is 3. If you were doing this completely by hand, the top equals 3, which makes it equal 0. Not by hand, do you see this intersection right here? Second trace 5, move over there a little bit, push enter 3 times, and it tells you it's at 3. So negative 2 and 3 go on my number line. Would you agree it's positive, negative, then positive? I want less than or equal to 0, right? The answer is negative 2 to 3, where the 3 gets a bracket, but the 2 doesn't. Someone tell me why. At negative 2, it didn't equal 0. It was undefined, right? If you look at the graph, it does not equal 0 at negative 2. Does everyone agree? So that's why, that's the weird case of an undefined point. So James, you were talking about that earlier, not knowing when to put parentheses and brackets. So when you find your zeros, just mental note anything that's not a 0. Okay, any of them, I know I'm not doing them all. Every single one. Get 0 on one side, put it in y equals, find the intersections, draw a sign chart, draw a number line. This is your homework. Use your calculators heavily on this one. A lot of teachers don't even show you the sign chart by hand. They just have you look at the picture. A lot of people have a hard time with interval notation just from the picture. The sign chart seems to help with interval notation. So I went ahead and showed you that. But how do we feel about it?
Easy.
Easy? Good.
I already did it.